In this video, I will discuss our motivation for the development of thin-ply reinforcements for the improvement of compression after impact strength. When a composite structure suffers impact, typically the amount of damage that is externally visible is quite small, such as this dent that we can see here. However, the damage to the back face of the structure, which is not externally visible, is usually much larger. And also within the structure we may have large delaminations, which is shown on this ultrasonic scan, which will further reduce the strength of the structure without being easily detectable during a visual inspection. To deal with this issue, airworthiness authorities have introduced the barely visible impact damage criterion. What this means is that the smallest impact damage, which can be reliably visually detected, needs to be determined, along with the associated internal and back face damage. And with all of this damage, the structure should still be able to withstand ultimate load, that is 1.5 times the maximum load which is expected in service. What this means for a structural designer is that it is not the ultimate strength of the structure which is driving the design, but rather the residual strength. And therefore increasing the residual strength of the material can allow structural margins to be reduced and therefore brings weight benefits. For over the years, many researchers have attempted to improve the residual strength of composite materials. However, we believe that further improvement is possible if we exploit a new class of emerging structural design concepts, which is that of ply-level and interfacial structures. An example being the crack arrestor developed by Minakuchi and others to stop cracks in an adhesive bond. However, in this research, we are not trying to improve the performance of an adhesive bond. Instead, we want to improve the compression after impact strength of a composite laminate. And that means we want to be able to reinforce each interface within the laminate rather than just a single bond line, and that we want to be able to minimize the disturbance of the load-carrying fibers in order to preserve as much compressive strength as possible. In further videos on this website, you'll find an explanation of our concept to achieve this, as well as an overview of how it performed.